angles. Okay, so you guys have already studied the measures of, like, when you watch that any outie video, that was about the angle falling inside the circle and then the angle falling outside the circle. So today, I think when we're looking at a figure, try to distinguish between, like, are we talking about angles here, or are we talking about segments? So today is the last lesson on all of these rules. So it's kind of a breakaway from, you know, like, after this, we're actually, formally speaking, we're almost basically through with geometry after this lesson, because everything else after that is probability, with a slight, like, discussion about geometric probability, but nothing, I mean, something that you guys have seen before already. So this is kind of like the last of the lesson, something to celebrate, I suppose, in terms of being done with just the geometry stuff of this year. So with that, this section, I'm not going to prove or do the proof, and you guys don't have to do the proofs on the homework assignments. I forgot to mention that because I saw a couple people in 5th period do the proof for tonight's homework. So you don't have to do the proofs. For this one, you have a formal statement written above. And again, just if you see the symbol on your notes, for some reason the circle symbol didn't come across. So when two chords intersect inside a circle, the product of the segments of one chord equals the product of the segments of the other chord. Informally, you guys won't hear me say that. Informally, I'm always going to talk about, like, two little pieces of one chord equals two little pieces of the other chord. And we're talking about multiplication here. So if I can have you guys cross this off, because this statement is actually written incorrectly here. Okay, so I'm going to have you guys trace along with me so that you can follow. But do you see how AP, I call AP like a little piece. Okay, so this piece, and then if you guys times it with that piece, okay, AP times PB, and maybe I'll put a time symbol in between here. So if you guys can remember, like, it makes like an X here. So AP times PB. Okay, so that's how you're going to remember it. So AP times PB. So the product of two little pieces of one chord equals the product of the two pieces of the other chord. In the chat, what do you guys think the rest of the statement should say? Times the two little pieces of the other chord. What do you guys think the rest of it should be? Yes. Okay, so not too hard to remember. Notice that we're talking about segments. We're not talking about angles. Okay, so it's the length of each one of those segments. So very good. CP times PD. Oops, I'll just put the time symbol as that. Okay, so if we're looking up at the formal definition, they might refer to secant segment and external segment. So I'm just going to, and that this is going to be the two rules that follow. So the secant segment is the entire segment here, which I'm going to highlight for you guys so that you have the distinction. But the secant segment would be CP here, or PC. Secant is defined, and we see this definition all the way through calculus. I talk about secant and tangent lines all the time in calculus because that's where the definition of the derivative comes from. So CP is what we're going to call our secant segment. And what defines a secant segment that's different from a tangent is that it crosses at 2 points on the circle. As opposed to a tangent line, you guys would define a tangent line as it touches just a single point on the circle, whereas a secant touches 2 points. External means outside. So when they refer to the external segments, that's referring to this little guy outside here on the secant segment. So the external segment part is the PB parts or BP parts. Okay, so it's that little segment on the outside. And I probably should have, since that's a segment for the secant, instead of draw the line symbol, I should have really drawn the segment symbol, which doesn't have the arrows at the end. So PC and PB. Okay, so when the formal definition then refers to that, I'm just going to bypass that because I think it's confusing for a lot of students to read that and be like, what are they talking about there? So underneath that formal definition, there is in quotation marks what I'm going to refer to as how you guys are going to remember how to do these problems. Okay, so on the circle that you guys notice, so this is different from, do you guys remember when you've learned the very first lesson with tangent segments and then I talk about like an ice cream cone? Okay, so with that one, you know, like the ice cream like fit nicely into the cone, right? So if you guys look at this, does it look like the ice cream is bigger than the cone? Okay, so this is gonna be the difference between what you guys learned before, and then now for these segments, it's gonna be the entire segment. So I'm gonna trace the entire segment for you guys. That's PA. Okay, so when it says the whole times the piece on the outside, it's gonna be the whole piece right there. And then times the external segment, which is the segment on the outside. Okay, so AP times BP is equal to, and if you set it up the same way, then it would be the green part is the whole entire segment, and then the yellow part is the piece on the outside. Okay, so the whole times the piece on the outside equals the whole times the piece on the outside. So go ahead and complete that statement. Just double check that you guys have the correct statement. So the whole length of the secant segment times the piece on the outside equals the whole times the piece on the outside. Okay, and our very last one here, you guys will notice that it's kind of lopsided now, but it's really the same thing, but a special case of it. So if you guys apply the same pattern that we were using earlier, if you trace the whole entire secant segment, that's BP. And then the piece on the outside would be the AP parts. Okay, so I'm going to start with that. So the whole piece, BP, times the piece on the outside is AP. Now, if we tie it to now what looks like just a tangent segment, then the whole tangent segment is going to be, and I'll show you guys, the whole tangent segment is TP. And if I asked you guys what is the piece of that tangent segment on the outside, you would say, well, it's also TP. So then instead of having the whole times the piece on the outside, it's just the whole, which is TP, times the piece on the outside, which is also TP. So for this one, it's TP squared that you see in the definition above. So the whole times the piece on the outside equals TP squared. So that's if it occurs for the tangent segments on the outside. Now we're going to do a total of 4 examples, and then I'm going to have you guys practice a little bit on your own. Okay, so in this case, you guys have, I think what I ended up doing was question number, I want to make sure I check some of these questions that have okay, we're going to do number 4 for sure. And let's do 3 and 4. Okay, and there's a little bit more space up above here. So I'm going to do 3 up above here. You guys don't have to label, just like watch my labeling of it so that it doesn't get confusing. So the TU is the entire segment. And so what you guys have to determine is what rule you're going to use. So I'm going to trace it, color code it for you guys. TU is 10 radical 2. And then they tell you guys that QU, that this segment right here is equal to 2 rad 2. And I'll zoom in a little bit. Then after that, RQ is 8. Find RS, find the whole entire segment RS. So if I look at this and I'm trying to determine, was it the first, second, or third rule that we apply here? These are 2 chords that intersect. So it's all about the little pieces times the little pieces equals the product of the little pieces on the other chord. So now it's with these types of problems, you then have to determine, okay, well, did I get the right information? Did I get the little piece information, or did I get the whole piece? So let's focus on this pink and purple one. The pink segment is 10 rad 2. The purple segment right here is 2 rad 2. So what I need though is the product of the 2 pieces. So let's see if you guys remember this from Algebra 1 or first semester, because we talked about it briefly. How do I figure out what the length of the segment TQ is equal to? If the whole thing is 10 rad 2 and the little one is 2 rad 2, do you guys remember how to find what that little segment is equal to, Brooke? Okay, subtract it. And someone said divide in the last class. Subtraction is correct because, you know, the sum of the two pieces is it should be equal to the whole piece. And now, so good, Joanne. Does anyone remember the rules on adding and subtracting radicals? Like how do you add or how do you subtract 10 rad 2 minus 2 rad 2? You, go ahead. Very nice. So you think of it as like radicals or like terms. You're going to subtract the numbers on the outside. 10 minus, think of it as 10x minus 2x. 10 minus 2 is 8. So it's 8 of that something, which is rad 2s. So 8 rad 2 is the correct answer. So I'm going to say that this is 8 rad 2. So now if I start to set up my problem for number 3, I have the two pieces are 2 rad 2 and 8 rad 2. So I'm going to have 2 rad 2 times 8 rad 2. The product of the two pieces of one chord equals the product of the two pieces of the other chord. Okay, so now you guys have 8, that's RQ, but you don't know what this other piece is. So if you don't know what it is, you're going to assign a variable to it. So let's call that variable, X. Okay, so then that's all equal to 8 times X. Is everyone okay so far? You guys know where all this stuff comes from? Okay, so now what do you guys think the answer to this is? Okay, go ahead and type into the chat. Do you guys know what the answer to the product of 2 rad 2 and 8 rad 2? Good, Nicole. Good, Lucy. Okay, so in case we forgot, when you guys have two numbers that you're multiplying like that, so good to review for algebra 2 too. It's 2 times 8 first, which is 16. And then rad 2 times rad 2 is just 2, or you guys can think of it as square root of 4, which is 2 as well. So 16 times 2, which is 32 in total. So you guys have 8x. And then if you guys don't multiply it together, you leave it like that. I'm just going to talk to you guys also about simplifying. So if you have the product of 16 and 2 on top and then 8 at the bottom, as long as it's multiplication, you guys can do things like 8 goes into 16 twice. And so what we have left is just 2 times 2 or 4. 32 divided by 8 is also 4. So that's two different ways of doing the problem, and that's a little bit of mental math, so you don't have to actually simplify the product, especially if the numbers get big. Now, if I go back to look at the question, it's not asking me just for QS right here, but it's asking me for RS. So in the chat, what's your final answer for this? What's RS equal to? And please remember to do those things on the test. Go back and read the final, what the question is asking for. Do you guys multiply or do you guys add when you're finding the length of two things? Good. Okay, so like, yeah, if something measures out to be 8 and the other one measures out to be 4. So this is 8. We solved for X, it's 4. In total, it's 12 is the correct answer. Okay, I picked 3 and 4 because of the radical stuff, like it's kind of a good refresher. And then 4 because of quadratics. So for number 4, I'm going to erase my image so that I can clean it off for you guys and then label stuff for you. So RS is the whole segment here. So it's like, be careful, you guys, if they give you the whole segment, you know that you need the pieces. So RS is 17, TQ is 18, and I'll zoom in on the diagram. TQ is 18, and then QU is 4. They're asking for what RQ is equal to, so we'll label that X. So take a moment and look at what you guys have. Okay, so we definitely need expressions for just the pieces. So that's what you're going to try to do. So let's start with the one that we do have the pieces for, which is the QU and the QT. So for this segment, we have the pieces, right? We have the 4 is QU, and we have the TQ is 18. So the left side, I'm going to write out the one that I already have information on, the 4 times the 18. Okay, after that, then it's about the little pieces on the other end. Well, since we're trying to solve for RQ and that's a piece, I'm going to say X is one of the pieces. Notice that in pink, I said that the whole segment RS is 17, that this little segment is X. What's an expression? Go ahead and type it into the chat for the segment that I'm highlighting right here. What's the expression for that, since we don't know what that is? Okay, good. So it's either always like adding or subtracting. It's 17, which is the bigger number minus X. I noticed someone put X minus 17. It's the whole minus the little piece, so 17 minus X. So it's the product of X and 17 minus X, because that's the other little piece. Okay, let's see if you guys remember. I think I had one person in 5th period remember how to solve this type of equation. Okay, Algebra 2 trig. When you guys start Algebra 2 trig, the first chapter is going to be about lines, which I know you guys will do just fine on. The second chapter is where I start to see students struggle a bit more, because it's recalling stuff from Algebra 1. And for you guys, you're telling me that some of you learned this like after the pandemic hit, solving quadratics. Do you guys remember? Quadratic formula, factoring, solving by square root method. You don't know when, okay. So, okay, the process is, after you guys have an expression like this, you have to distribute everything and then get everything to one side. Okay, so move everything to one side. So you have to isolate it, make sure one side is equal to 0. So add x squared, subtract 7x. So you have x squared minus 17x plus 72. So I'm adding the x squared over to the other side, subtracting the 17x over to the other side, and it's positive 72. We set this up this way because now there's a number of methods that you guys learned in Algebra 1. Factoring being one of them and quadratic formula being the other one. Advanced kids will almost always try factoring first. And if factoring doesn't work, they'll move on to quadratic formula. That's going to be like rinse, repeat for half of Algebra 2 trig, is this concept of like solving quadratics, solving polynomials. It's always the same thing. So I'm going to just quickly refresh your memory on factoring. It seems like most of you guys learned factoring by X method. And with X method, you put the value of A times C on top. So A is 1, C is 72. Okay, negative 17 is on the bottom. What you guys try to do is think of the two numbers that would multiply to be 72 that add to be negative 17. Let me give you guys a moment. What multiplies to be 72 that adds to be negative 17? Good, Nicole. Good, guys. All right, so I'm gonna say that negative 8 and negative 9 multiplies to be positive 72 that adds to be negative 17. There is a shortcut, but before the shortcut, I'm gonna talk to you guys about like a way that always works versus the shortcut, which only works for certain instances. So you might or might not have learned after the X method that what you do is you guys keep the X squared the same. So the X squared and the positive 72, the first and the last term will remain the same, the X squared, the 72. The middle term, which I'll highlight in green, the negative 17x is now going to be rewritten as negative 9x minus 8x or negative 8x minus 9x. It doesn't matter which one you guys choose. So let's say you do negative 8x minus 9x. Notice that the expression I have, it's still x squared minus 17x plus 782. I just separated the negative 17x to be negative 8x and negative 9x. And after that, you guys should have learned a method of factoring called factor by grouping. So if you group the first two and x is the GCF of that, you guys can pull the x out and you guys got x minus 8. On the last two terms, if the third term happens to be negative like it is here with the -9, then you guys can take the -9 out. And then what you'll see is that factoring the GCF, you should get the same exact binomial as the first one. I think I reviewed this with you guys before, right? No? Does this? Okay. So then after that, if you look at this, this is technically two terms. X minus 8 is in both of those terms. So if you pull the x minus 8 out, so think of like factoring out the x minus 8 from that, what you have left is x minus 9. Okay, the shortcut way, which is what a lot of students tend to go to, is that Mrs. Kim, we already have the -8 and we already have the -9 from the x method. Can't we just put it there? And yes, you guys can, as long as x squared has a 1 in front of it. If x squared has a 1 in front of it, you guys can use that shortcut and bypass the grouping. But if x squared has got a 2 in front of it or 3 or a number other than 1, you can't do it that way, no shortcut, and you have to do the grouping way. So I know in Algebra 1, we actually discourage teaching shortcut just because students will inadvertently use the shortcut when you can't use it. So x minus 8, x minus 9, and remember that it has to make sense, you guys. The factoring is reverse of foiling. So whatever you guys do, if you foil in your head, the answers that you guys get should match the original trinomial to begin with. Okay, so this is all equal to 0. Solving by factoring means you're solving for the two x values that x could be. So x can be 8 or x can be 9. And if this represents a physical situation, which it does, this is the length of the cord, then the values that you guys get must be positive. So since 8 and 9 are both positive, then RQ, being the value of x, can be two values, 8 or 9. And that makes sense because if you guys think about the equation that we set up, if x is 8, then the other piece must be 9. If x is 9, then the other piece must be 8, both of which have a product of 72. Okay, so that's your answer for that one. Okay, the last two problems that we're going to do is going to be number 6 on one of them, and then what was the other one? 8, 6 and 8. Let's do 6 and 8. Okay, so different picture. The lopsided ice cream cone with too big of an ice cream. Okay, so HG is 8. And then you have GF is 7. This one always tricks students, like this one property. So I'm going to erase this for now. Let's see. So you guys have DF is 21, and I'll explain why it tricks kids. And then the question is, what is EF, which we'll call X. Let me zoom in on this. Okay, you guys, so the rule itself, I'm going to use the top one to explain the rule. The rule itself is the whole entire secant segment times the piece on the outside. Okay, so the top one is easy. It's 21 times X. Okay, the bottom one is tricky. Okay, if you aren't given the whole piece, then what is the measure of the whole piece of the bottom one? Good, Nicole, that's correct. What's the measure of the whole piece? Okay, it's 15. And you know what I see students doing a lot is just doing 7 times 8 because they think it's the pieces one. So it's the whole piece, which is 15. So let's set up the equation now. We have, for number 6, we have 21 times X equals 15, which is the whole piece, times the piece on the outside of the bottom is 7. So it should be 15 times 7. I'm going to stop right there. Does anyone have any questions on where any of those numbers come from, particularly the 15? Okay, when we divide, let's say I don't want to multiply 15 out times 7, and I divide over by 21. I do notice that I can reduce certain things. Like, for example, I can reduce the 7 and the 21. That's 1/3 or over 3. Then the 3 goes into the 15. How many times after that? 5 times, right? So my answer is just 5. And the question was asking for EF, which is X. So X is my answer. That's EF. The question someone asked was, how can we add the two numbers? The rule on this property is that you have the whole piece, which on the top is 21, times the piece on the outside, which is X. On the bottom, you don't have the whole piece. You have this piece is 7, and you have this piece is 8. So the whole piece is something that you have to come up with. It's the sum of 7 and 8, which is 15. Does that make sense for the person who asked? And I'm pretty sure there's a question like this on your test, you guys, and that's the question, the last question we're on here, number 8. And I'm curious to see how you guys do with this now. Just setting up the problem. So number 8, I'm going to erase what I have here so I can label it for you guys. And you have DF is 25. EF is 4. And then HG and GF are both. So this is X and this is X. Sorry, you can't read that one, but if you can't read that one, that's 4. Okay, on the left-hand side, can you guys set up and tell me what times what is for the top secant? What times what should go here for the top secant? Okay, good. It should be the whole times the piece on the outside. So 25 times 4 is correct. I don't think anyone got this next part right in 5th period. What should go on the right for the bottom one? What do you guys think the bottom one should be? Very nice, you guys. Okay, follow the pattern that you guys did for the above. So think about what you guys did for the above. What is the whole on the bottom? Okay, much better. Okay, so the whole is 2x. It's x plus x, which is 2x, and then the piece on the outside is x. So that's going to be the trickiest the question gets for the test, is like you have to add the two things together and forgetting to do that sometimes. Okay, so we get 100 on the left. You guys got 2x squared here. The first way you guys learned how to solve quadratics before factoring was by square root method. And you can do that so long as you isolate x squared first. So if we don't have a bx term, the fastest way to solve this is isolate x squared. So you have x squared equals 50. And then at the point where you have just a constant on the right, at that point to undo squaring, you guys take the square root of both sides and then simplify your answer. So what is the correct answer for this? X equals. Okay, good. And so it's 5, 5, 2. You guys are so much faster than the beginning of the year with simplifying radicals. In theory, in Algebra 2 Trig, if this problem was just like a problem that did not pertain to a picture or to a physical situation, there should be a plus or a minus that goes in front of it because both are possible answers. But when we consider the fact that x represents the length of something, then you can't have a negative length. So the only possible answer is the positive version. So x is 5 radical 2 is only one possible solution, as opposed to the above where you guys had 2 answers that worked. This one only has 1 answer. Okay, so hopefully